electric car was built by chemist Robert Davidson in Aberdeen, Scotland in 1837, 48 years earlier than the first internal combustion car. Thomas Parker built the first practical electric car in London in 1884. Electric cars have a battery instead of gasoline tank. Electric cars also have electric motor instead of an internal combustion engine. While charging the battery may increase pollution at the power plant, total emissions associated with driving electric cars are still less than those for gasoline cars.
While today's cars are much cleaner, burning gasoline still creates harmful tailpipe emissions that contribute to climate change and smog. How are electric vehicles different? Electric vehicles produce no tailpipe emissions. Even with the use of electricity, total emissions associated with driving EVs are still typically less than those for gasoline cars, particularly if the electricity is generated from renewable energy sources like wind. Electric vehicles have a battery instead of a fuel tank, and they have an electric motor instead of an internal combustion engine. The motor uses electricity from the battery to power the wheels. The motor can also charge the battery by recapturing energy that would otherwise be lost during braking. The number of miles an EV will travel before the battery needs to be recharged can be found on the Fuel Economy and Environment label or at fueleconomy.gov. To recharge the battery, just plug the car into a household outlet. Most EVs can be charged with the standard 120-volt outlet. A 240-volt outlet, like the one your dryer or electric stove uses, will charge the vehicle more quickly. Check the window sticker for the charge time of the vehicle. You may also be able to plug in at work or at a public fast charging station. Plug-in hybrid electric vehicles, or PHEVs, have a battery and an electric motor. They also have a gasoline tank and an internal combustion engine. Some PHEVs operate exclusively or almost exclusively on electricity until the battery is nearly empty. Then, gasoline is burned in the engine to generate additional electricity for the electric motor or to power the wheels. The fuel economy label shows the vehicle's driving range using only electricity and the total number of miles it can travel if you start with a full battery and a full tank of gasoline. Blended mode PHEVs use both gasoline and electricity to power the vehicle while the battery is charged. When the battery is nearly empty, the internal combustion engine uses gasoline to power the wheels alone. Some blended mode PHEVs can travel a short distance using only electricity. You can recharge PHEVs at home or at a public charging station. Since PHEVs typically have smaller battery systems than EVs, they recharge more quickly. Since a PHEV can run exclusively on gasoline, you can still drive it even if you rarely or never recharge the battery. However, it costs less per mile to run on electricity. That means the more you recharge, the more money you'll save. Plus, you'll also reduce harmful tailpipe emissions. Very high speed or aggressive driving, cold temperatures, and frequent use of the heater or air conditioner may lower how far you can travel on electricity. Remember to consider your typical driving conditions and driving style when deciding what type of vehicle is right for you. Learn more at epa.gov/green vehicles and fueleconomy.gov.
Part 2. Materials. There is many materials that have been used to create an electric car just to make sure people get a maximum safety and comfortable. Let's take a look at an example of materials in electric car. Parts such as iron and steel, copper and natural rubber. Iron and steel used in car body, car mufflers, decorative trims and exhaust. Copper used in braking system, electrical driving system and gearbox. Natural rubber used in tires, wiper blades, engine mounts and seals.
Iron and steel used for car body, car mufflers, decorative trims and exhaust silencers. Steel is made up of iron plus small amounts of carbon. Specialty steels also contain other alloying elements, but all steels contain carbon since in the production process it's difficult to remove carbon. The basic room temperature structure of iron and steel is called ferrite. Advantage of iron and steel: predictable, easily reshape and restore, requires no special joints when crafted into vehicles. Disadvantage for iron and steel: high maintenance costs, need to be painted to make it corrosion resistant, very small resistance against fire.
Next material is copper. It is used for braking systems, electrical driving system gearbox, and vehicle electronics. Copper is a reddish material with a face-centered cubic crystalline structure. It reflects red and orange light and absorbs other frequencies in the visible spectrum. Due to its band structure, it has a reddish color. It is malleable, ductile, and an extremely good conductor of both heat and electricity. It is softer than zinc and can be polished to a bright finish. These are advantages of copper. Excellent conductor of electricity, great heat resistance, high flexibility. These are disadvantages of copper. They can corrode. Intolerance to electrical surge. Electromagnetic interference.
The third material is natural rubber. It is used for tire, wiper blade, hoses, belts, engine mount, and seals. Properties of natural rubber. Natural rubber combines strong tensile and tear strength with excellent fatigue resistance. It has a great green strength and tack, which means it can attach to itself as well as other materials, making fabrication easier. Natural rubber adheres well to a brass-plated steel cable, making it perfect for use in rubber tires. Advantages of natural rubber: it is durable, abrasion resistant, vibration dampening, costs less than many alternative polymers. Disadvantages of natural rubber: it is low cost, reduction in tensile strength, elongation, and other physical properties. It does not have very strong heat resistance and is only able to withstand temperature as high as 180 Fahrenheit.
Cotton used for car covers and car seat. There are two types of properties for cotton, which is physical and chemical. For physical properties, colors of cotton, strength of cotton, elongation at break of cotton fiber. For chemical properties, its effect of sunlight, effect of heat, and effect of alkalis. Explanation of physical properties. Colors of cotton. The color of cotton is normally creamy white. If the picking of cotton is delayed, then it may be turned to gray, yellow, or bluish white. For strength of cotton, cotton has a tenacity of 3 to 5 grams per denier. Generally, it has a tensile strength of 40,000 to 120 pounds per inch. Also, the strength of cotton is very important and can be improved by mercerization. Generally, cotton strength is checked by a Presley strength tester. For elongation at break of cotton fiber, when a fiber is subjected to force, this will stretch to some degree before it breaks. This stretching is called elongation at break. Cotton does not stretch easily. Generally, it has a long elongation at a break 5 to 10% depending upon a variety of cotton. Explanation of chemical properties. Effect of sunlight. There is a gradual loss of strength when cotton is exposed to sunlight. It turns yellow for a long time. So much damage caused by ultraviolet light and by the shorter wave of the visible light. Effect of heat. Cotton has excellent resistance to degradation by heat. So it begins to turn yellow after several hours at 120 Celsius and decompose remarkably at 150 Celsius. Cotton is severely damaged after a few minutes if 240 Celsius. Effect of alkalis. Cotton has excellent resistance to alkalis. It swells into caustic alkalis but is not damaged. Also, it can be washed separately in soap solution without harm. It is characteristic of the glucosidic linkage of the cellulose molecule that it is highly resistant to alkalis. At normal temperature, weak solution of caustic soda has no effect on cellulose, but on boiling in NaOH, a small part of cellulose passes into the solution. There have advantage and disadvantage of cotton. For advantage, very durable, super soft, easy to wash and dry. And for disadvantage, not very stretchy, prone to shrinking and expensive.
The next part is product performance. First material is iron and steel. By using the materials that have been listed, this product is able to provide the best performance. For example, by using iron and steel, the product are more safer when crashed. Steel can be engineered to collapse like an accordion. Most electric cars on the road today have a steel front end that perform like this. Steel also has the ability to become harder when it crashes, which means it will become stronger on impact, allowing the steel to absorb more energy. Most production vehicles launched to the market today use new generation, advanced high-strength steel and technologies, which will make a car not only safe but also stronger when vehicle crash happen. We all hope that we won't ever be in one accidents do happen. The best preparation to avoid serious injury is to demand and drive the safest vehicle designed with the best material for crash protection.
Next is copper. Today, copper plays a critical role in a cars for functionality, efficiency, comfort and safety. Even the most basic model contains some 1 kilometer of wiring, mostly used to carry data, send control signals and supply electrical power. For example, copper can improve our brake system and make the technology of the car function well.
The last is natural rubber. The most important performance requirements of a tire are safety and comfort of mobility, along with reduced environmental impact. These requirements are best met by deploying a combination of technologies on both a microscopic and a macroscopic level in design and manufacturing. This chapter discusses examples of such technologies. It also discusses natural rubber, the most important raw material used in tire, including its quality control and the challenges facing its use in the future.